establishing a digital reality ecosystem.
Moving to a visual way of working.
From laser scanning to virtual reality.
That's our mission.
Which will serve as a foundation for our 3D visual assets platform.
We're doing something for the industry as well as multiple industries. But to do that, we can't go alone.
Call to action. There's a couple of efforts that we're joining up with, this being one of them, and the Reality Capture Network is something that's near and dear to our hearts to help try to push forward, to help all of us. I think we all succeed whenever we get better alignment for what we want and what you guys end up wanting at the end of the day.
Hey, good morning, Boise. Good morning, Reality Capture Network. My name is M. Full name is Athicha Dhanormchitphong. I work for ExxonMobil, and I've been with the company for close to 2 decades. First decade was really a lot of programming, software development, web and desktop. And then the last 10 years was a lot of R&D efforts, which really culminated to the great work that all of us are doing together inside ExxonMobil. I'm the digital reality ecosystem architect. It's nice to meet you all.
All right, everybody, my name is Kyle Daughtry. I've been with Exxon about 17 or 18 years. A bunch of different roles in technology and digital over a period of time. Myself and Em met up a while ago and started down this journey of how do we actually move the company to a visual way of working. My particular role now is I'm the discovery and strategy manager for Daughtry, this digital reality ecosystem. For folks that don't know about it, we'll talk a little bit about it today. For folks that do, this will be a little bit of an update and hopefully a good teaser.
So, moving to a visual way of working. That's our mission that we've been working on for the past 3 years and probably about 8 to 9 years of research that led to this. The project is the Digital Reality Ecosystem Project. But really what matters is those bigger words, move into a visual way of working. Because what you'll start to see is we've been laying the groundwork for ExxonMobil, and the folks inside started interpreting moving to a visual way of working on their own. And you'll understand a little bit more in that story.
Yeah, to lead into that, or ultimately lean into it, we want to give you a bit of an overview of what we're doing with Daughtry. So for the folks that are new to the conversation, at least haven't seen the last couple of years that we've been doing a presentation, give a bit of an overview of what we're calling the layers of spatial data. We'll keep on saying it over and over again, but space and time is everything to what we're building, and it should be for most people. We'll talk a little bit about the use cases and show some of that off a bit. Our aspect of what we're doing, reality first, and how that's driving a lot of the use cases that we're actually accomplishing. And then one of the probably most important pieces is this aspect of a call to action. We talked about it a little bit last year. We've got a little bit more of a call to action to join some groups to help keep pushing these efforts forward, including this particular group of people here. And then at the very end, we'll show an updated teaser reel of what we've been doing inside the company.
Gotta end it with a video. All right, overview. For the folks that have already seen our presentation, obviously it is an update, but please be patient with us. We want to make sure that the folks that do not know about the project are aware of what is that background. What are you doing exactly? So you're going to be drinking from the fire hose quite a bit, but hopefully this Venn diagram is familiar with some of the audience members. It is how ExxonMobil has been shaping the definition of the digital twin for us. And so I'll start on the top right? Visualization, data aggregation, and then analysis, simulation, and modeling. And the healthy center is really the component, those are the components that really matter to ExxonMobil. And so you're probably wondering, what is that capabilities periodic table? And long story short, there's 255 definitions according to a military white paper.
Yeah, there's a three-dimensional matrix that shows the different definitions of twin.
Right, and as our journey has continued on, we've met a lot of folks in this landscape. The word digital twin, you might interpret differently as how we interpret it. So what we've started doing is passing out this periodic table to folks that we work with, or the companies that we work with, to basically say, what are those capabilities that you deliver as well? And at the same time, internally, we use those capabilities to really understand, what are we missing? And what's coming up? Are we lacking any capabilities, for example? And so I do want to give an example, right? Visualization. How many folks here use Google Maps or Waze? Cool. That's the road on Google Maps. Data aggregation. Yeah. Data aggregation. Cops on the road. Traffic flow, right? And the simulation piece. We were at the Marriott this morning, and we had to figure out how long it would take for us to get to the Morrison Center, right? And so it told us, hey, if you took a scooter, it'll take you 12 minutes. So, perfect example of really how we shape the components, or the components of the digital twin.
Yeah, the only things I'll layer on top of here is it's no desire for us to define a definition of a digital twin. It's really this maturity of all these data components. And that huge shout out to the Digital Twin Consortium on that periodic table. We'll talk about that a little bit more in the industry side of stuff, but a big shout out there. So we wanted to give a little bit of a grounding on where this is data product-wise inside of the company. There are a number of different efforts that are in that, that previous slide that show the three parts of the Venn diagram. There's work efforts at a global scale of how do we master all of our equipment and data in 1D, engineering data, inspection data, all of that into a master record or an aggregator. Really, really cool efforts that are going on there. There's also a big effort for how do we actually take all of our drawings and move to data. And essentially say, let's get out of that whole paper-based mess and move from, I've got a PNID to I've got a set of data points, and then I can recreate those PNIDs however I want. Great work there. And what we're really, the heavy focus for us right now, for our particular group, while our other sister groups work on those other areas, is around how do we actually create a system of record or a source of truth in that aspect of spatial and visual data. So the what and where, and give more clarity to that for folks that are out there. So that's probably going to be most of the time that we'll spend. We'll be talking about, again, spatial and visual data.
So what is DRE then? What is the digital reality ecosystem? In short, it's an ecosystem of digital twins. We talked about the components, right? Our mission from our executive is to make sure this is scalable. Corporate scale and integration is your mission. You can't do it just for one site. You got to hit them all, down, mid, up. So how do we do this at scale? It's not going to be a single solution, a single service for our single platform. It comes down to what Kyle was talking about too, and what we've kind of been alluding to is data, space, and time. We've got to make sure that we lay out the foundation for that to enable really an ecosystem of solutions that play nice with our data, open and interoperable. If you look right here, these layers right here, that's all we're doing is stacking layers on top. So that way it gives us the ability to have specialized view or a holistic view, really providing contextualization and information at the right time for operators to make the right decision. Modular, open, agnostic, based on industry standards. Why are you doing that? We did the total opposite. We stayed closed, proprietary, right? And we went on the journey with monolithic stacks. We started building out functionalities with those monolithic stacks. We got locked in. Our data was not owned. And so we paid those prices. So naturally, we did the total opposite. Yeah, and
end of the day, the effort is heavy focused on that aspect of data and modularity. None of this is new from the spatial and visual data for this group, right? This is bread and butter. But we're putting a big stance of data as our foundation for pretty much all of it. So what is that open, interoperable digital twin that we kind of talked about at a high level, or that aspect of the Venn diagrams and how do we integrate data? It's really us focusing on open, the aspect of how do we make sure that we tie all of our particular efforts to as much of industry standards as possible, whether that's data sets or best practices or work efforts. And there's a lot of areas that are actually matured, that are maturing even more now on how to store and manage and MOC and do all of the great things in the industry standard aspect of stuff, but also to remain interoperable. So you got your data in a standard format, so I can use it at any point in time, and I've got interoperability between our systems that allows us to be able to use the tools that we want. The biggest reason there is that there are many different particular use cases for a particular technology, and we want to focus on that capturing many times, and then ultimately reusing it many times. So I'm gonna spend a little bit of time focusing on this thing that's spinning around for you right now. What we started with is building out the core components, or these pillars that we've called them, of capture, store, deliver, and consume, and then this digital thread. And it's a novel kind of conversation, but at the end of the day, there are roots that we've been building around data interoperability and ownership in each one of those spaces. And I want to talk to you about each one of those. On the capture aspect, the biggest push for us right now is how do we democratize capture? So from one aspect of it, how do we actually set the right guardrails for our capture providers, whether I'm doing planning jobs or I'm doing a turnaround or I'm doing something for emergency response or training. It could be anything. You're going to capture sometimes at different fidelities at that point in time, and we need to make sure that we give the right guidance so we get the right data sets. And to that data set aspect of it, we need to make sure we have the right formats and information as part of those guardrails. So we'd focused a lot of time up front to build those guardrails, and we're actually working across a couple of industry areas, including here, on how do we actually make those more public. The other side of capture is the aspect of how do we actually give people with phones more ability to be able to capture in real life, but then be able to tie back into that system of record and ultimately go back into our control, and all of it ties in together, which is for most people is not a really simple task at the end of the day. Setting good survey and control across the globe for the number of assets that we have is actually a hard feat, and then being able to control a bunch of people with their phones out in the field and capturing stuff is also another level of information that's hard to do. To that storage area, a little bit of a bold statement that we made over the past couple of years is there wasn't an open and interoperable storage location for spatial and visual data. I'll say that we've been working really hard, and there is one inside of our organization. We're working hard on that, and hopefully in some near future you'll see that become a bigger public piece.
We usually prefer buy versus build, but
heavy focus as much as we possibly can, work towards those industry standards to buy as much as we possibly can. To that delivery mechanism aspect of how do we actually build plug-and-play data systems. We talked about that Venn diagram. Let's see if this goes backwards. We talked about this aspect of the 3 different areas of data and the data products, right? And we also talked about, well, let's see if it clicks or not. It won't go back any further. We'll just talk about it, because I don't think it's going to go any further. There it goes. You've got these different areas of the Venn diagram, the top right-hand corner, the visualization, a lot of the data and the simulation. Well, all of those engineering systems, those inspection systems, we have to make that data plug and play. Meaning that if I'm using it in a digital twin tool today, I should be able to use it in the inspection tool tomorrow. And both of those data sets should be able to flow back and forth. And we've made really good inroads there with great partners that are here as well. All right, let's see if it'll click. Clickety-click.
That animation slide usually takes a while to go back, so apologies, guys.
There it goes. Okay, cool. To the aspect of how do we actually build anytime, anywhere consumption systems. And what we mean by that is we mean that not only from a technology perspective should I be able to use the right tools for the job. So if I'm needing to use a tablet today in the field, or I'm in one of our remote technology centers, I'm using a PC or even a high-end machine for some of our engineering. Being able to use any particular tool and still have the same grounding of data and information. But also to the particular use cases. Like we mentioned before, you're going to use, for engineering work, you're going to use a particular tool, but you're not going to use the same tool if I'm doing emergency response planning, or if I'm doing a training effort, or working on a set of procedures to build out in the field. And probably most important to that aspect of that digital thread, the reusability of information, and making sure that we both pull that information back to source and system, but also feed it back into the guidance and guardrails that we go forward on. Like there's a constant cycle of that. Biggest thing here is many uses of data. At the end of the day, I think we all win if we use the information more.
Can I talk about that real quick, that digital
of
thread a
course.
little bit more real quick? I do want to touch this one piece. So mission is to scale. You've got guardrails, data coming in, being stored. We own that now, so that way we can consume it to whatever output that is. Mobile, cell, VR, AR, whatever, right? You know what we learned? Is that each site, if the data's not open and interoperable, they're not going to leave their platform. They start tagging things and creating these relationships. There's 1D and 2D relationships, which then gets isolated within that system, which then goes against our mission to scale. Right? And so that digital thread to save back, whatever you tag spatially, that's the key for us to scale. So that way we can go back to the plant managers to say, not only are we saving all your efforts, it will live on to the next system that is better, faster, smarter. Use cases. DIA process. We don't just select them, right? High value ones as well, but we have an entire process from discovery to incubate to accelerate. That's our ExxonMobil technology process, where we really dwindle down to the right use cases, the high value ones, make sure there are processes as well as owners involved and stakeholders. But at the same time from there, we incubate that at a site to make sure that it is scalable and interoperable. Then from there, we work with our scaling sustainment team to make sure that does get scaled out accordingly. You can kind of see those high-level use cases right there and where they are, from whether they're in discover or incubate, or they're already in acceleration mode or at scale already. But really the big picture for this slide is the storage, what Kyle was talking about. So capture, store, deliver, consume to the digital thread back. That storage component, we haven't seen one in the industry that is truly open and interoperable and agnostic. We've been out there talking about it, not only just what things look like, but also where things are. Key word, open, agnostic, interoperable. We're still looking for it.
All right, so we talked about that aspect of the components of a digital twin and those particular efforts. Well, this is a little bit of a view of the 8 big things that we're working on inside the company to try to mature for the ecosystem to thrive. And I'll start from the top, and then we'll take some of the second parts of it. Guardrails, mentioned that before, this aspect of what are the right data sets, what are the right modalities that we should capture in, depending on the particular use case of technology. And what are the right standards that we should be leveraging as part of those? To services, there's no way in the world we would be able to scale anything in our company without our service providers, our engineering service providers, our scanning companies. We're constantly looking for that aspect of how do we grow that across the global footprint. But that is how we thrive, is being able to work together to capture information and data. To storage, Em harped on it a little bit. Like we mentioned, we're pretty confident that we've got a system that will scale for us right now and hopefully will scale for the industry at some point in time. To the platforms, like we mentioned before, we've got this aspect of how do we use the right tool for the right particular job, and we're maintaining that ecosystem of platforms and continuing to grow as our foundations grow, and that's a big thing. So we constrained the platforms towards the beginning to make sure we got the right infrastructure set in place, the foundations, and then we're constantly seeing a growth in the number of platforms as use cases pop up.
Use cases, I already mentioned it, right? But remember when I started off the presentation and said move into a visual way of working? What happened is the sites started understanding and interpreting it their own way. They came back to say, hey, this is my use case. This is what I do currently today. And if I can move to a visual way of working, this is what I would do tomorrow, quantified by hours and values and dollars and things like that, right? And so those use cases are married up to the platforms, again, aligned with processes. But we hold those near and dear to our heart, right, to make sure that is scalable. External engagement is the next one. We're here. We're here to talk about what we're doing, provide an update, share our learnings. At the same time, we'd like to influence and validate, especially here at the Reality Capture Network. What better place to talk about what we're doing than to you all, the correct experts, right? Workforce enablement, near and dear to our heart. We lost a lot of really smart people during the COVID days. And we realized, too, as the Dre project started on this journey, folks started raising their hand and said, hey, I do game development, I do 3D modeling, right? And these used to be my hobbies. I didn't know this could lead to something inside ExxonMobil. Come join the Dre team then, right? And governance, global scale. There's got to be some form of governance. It's not one type of governance that we started learning. We got to have site governance. We got to have data governance. We got to have governance on how we tag things even. But there are tons of governance that we got to make sure so that way the sites are not doing any regretted work.
I think there's a lot of opportunity in that aspect of data governance for how do we make sure that we have the right technology to be able to do that effectively without eating a bunch of resources at site, which either happens now or we have engineers that are working for us to be able to do validation. All right, so we'll talk about layers of spatial data.
Oh, that's my turn. Oops, yeah. Excuse me, sorry about that. Layers of spatial data, right? We've been talking about data. Let's get right to it then. Simplest form, it's basic navigation. So we do reality captures. We create mesh models. Put 360s on our head and start walking with them to create Google jump points. We take aerial shots to get topside, UAV photos, right? And in its simplest form, we capture, so that way we can provide basic navigation for our folks to be there without being there.
Creating that ground truth all on the same spatial plane, right, in the world, right? End of the day, Google Earth style, to the aspect of how we're connecting 2D to 3D and bringing in things like firewater maps and blast zones, again, to the same space and time, and that's the biggest focus, so we can leverage the data that we've already got that's already spatial, but bring together information that might not already be spatial into the world. And it's a huge thing for us to be able to see that information. Now there's work efforts also as well to move a little bit past those drawing side stuff and into more data feeds and data enrichments, leveraging AI to be able to work some of that stuff. But for right now, end of the day, tying all of it 2D to 3D in the real world.
Reduce that cognitive load. Overlaying 1D data with 3D. That slide is not supposed to do that, but I think you understand what we're trying to do here. We overlay 1D with 3D so that way we can create those relationships. And as you see those blue boxes, that's really our bounding boxes. So that way this area, right, this geospatial bounding box area holds a relationship to these other types of data products. And that's what's being saved in the digital thread.
And we'll talk about it again here in a little bit about that reality first mentality. You've got your drawings, you've got your models. Well, and a lot of the times, we've got brownfield assets that don't have those drawings or models. And then maintaining them and keeping them up to date a time-intensive piece of work. And so you leverage the right information at the right time, build bounding boxes around things that are spatially reality capture, and then take that spatial data from your CAD that already exists. To combining in the aspect of from other CAD, like we mentioned before, internals of vessels, and allowing us to see that in real time. So as I'm modeling out a vessel and ultimately tying it into the real spatial plane, the same exact location, I can get a ton more, again, like what Em mentioned, context into the real world.
Now we can see the inside and the outside at the same time, right? So with capturing that data, combining it, overlaying it, and so forth, right, leads to all these other use cases. We can now take accurate measurements. We can view, we can plan, we can scope. Again, being there without being there was a big key for us. Do you know what? Some of our sites, this used to be a full-time job for an individual just to get elevation. Now we can do it at our desk.
Used to, still is sometimes.
I know, I'm being hopeful.
To projects and being able to tie in brownfield areas to new builds, really helping us gain alignment during that feed process or the detailed design work that would happen. This has probably been one of the biggest areas of simple data integration, but being able to tie together spatial data to reduce cost up front on those projects.
You see those colors, right? Red. Visually, something's wrong. Let's hone in on that. Versus sifting through spreadsheets to understand exactly where is something wrong. Reduce that time so that way you can tackle that problem as soon as possible visually. Turnaround and planning. Well, cranes, for example. Cost a lot of money for us to rent. And before we actually start executing our work, we got to plan where that crane needs to go, for example. Now, can you imagine if you didn't have a digital reality and you had to try to work out that route for that crane? Oh, it didn't fit, it didn't make it there, it's going to be an extra day, we're delayed. But be able to do that visually, to understand exactly where it fits or what it is going to collide to in the digital reality, has allowed us to save a lot of that time. Kyle talked about spatial awareness, right? But look at our work list. We can actually see from a top view where they are spatially now. And at the same time, we talked about layering data. Well, we can reduce certain contrast. So that photo down here is really a visualization of temporary piping. But again, where is that piping? Oh, at least I kind of have some context on where that is going. So that way we can have a meaningful conversation to get the job done.
This in the project space is probably one of our biggest benefit areas, for sure. Being able to spatialize data that you weren't able to and give context. To enhancing visual inspections. There's a really neat workflow that's being built inside the company with a couple of partners that we're calling Air 3D, allowing us to do anomaly detection, right, through AI, one particular company, feeding in all of the visual data into a three-dimensional model and being able to have the output of all of that information, red, green, yellow, depending on the particular anomaly, so you can see it all in the real world. Do not go through lists of information to determine anomalies for an inspection data point. Visually look at it. And Em likes to talk about this quite a bit. Well, now let's take that same information and put you in the field and be able to look at the anomalies from the field and all of the cuboids of information. And I've got more context now than I ever would. There's multiple different particular use cases here. Again, whenever you're building this spatial data, I can use it from above site, which is happening quite often, or hopefully, move into that aspect of leveraging it in the field as well. To the right-hand side of doing the same thing, internal inspections, and being able to spatially set that information and data.
I'll add one of our Asian sites. They actually created a deck that said, Dre has gave us superpowers. And so this slide really kind of marries to that a little bit, right, where they're like saying, oh, the technology that has been laid for Dre allows us to be able to see all the way up there. So technically, we have that vision. We also have X-ray vision, because now we can see the internals, when technically technology is just porting that data over to your device, right? But long story short, you've got the data in the palm of your hands or right in front of you, wherever you need it.
Now, if we just be able to take the superpower of flying, that would be great. I'll take that one.
You can do that in VR. So and that leads us to immersive technology. And if you notice, too, right, all these use cases, we're showing examples of reusability. Just keep that in mind. Whatever you capture, and those modalities that he talked about, right, we were oftentimes before using it single use and throwing it away. So that storage is a big key for us. So that way we understand what we own, what format, what modality, so that way we can reuse it. In this case, for immersive technology, I mean, our basic operator training program for our training organization, right? We take those models so we can provide folks just-in-time training or basic operator training. We also do design reviews with projects, so 30, 60, 90% front-end engineering designs. Going through that, walking through, understanding scale 1-to-1, so that way you can have a conversation. Why would you review a 3D model on a 2D screen? Review a 3D model in 3D. So that way, for example, hey, look, he's taller than me, and I can't reach this shutoff valve. Guys, there's a problem. Conversation over. Oh, sorry. Connected worker, for example, right? Again, hands-free FaceTime, but we're looking at 2.0. And the reason why we left that there is just, again, from the previous slide, if we are tracking space and time, we just need to understand how we localize ourselves. If we localize ourselves, now we can pull up the information beyond QR codes. So that's led us to things like GPS or VPS or IPS. And construction reviews. Taking your model, again, just overlaying to see exactly where things are supposed to be installed.
We'd like to call that will the couch fit?
Yeah.
Kind of the little coinage. To this aspect of augmented field procedures, it's one of the efforts that we're looking at, going into the future of how do I either build better job aids or actual procedures. And a lot of work's going into it from the aspect of doing it for machinery, for what we call virtual assembly. And that's with a partner organization, probably some of the best machinists that I know, building out these workflows. Now, one of the sides of this is how do I actually create that procedure guideline faster and easier, especially for us with as owner operators, that we don't always own the pump or the compressor in that particular scenario. Lots of great work within that space to try to push forward with the OEM side, but would love to connect up with anybody a bit more to see how they're doing that effectively. We're seeing a lot of really great gains in terms of alignment when they're going to their readiness checklist to make sure that they actually are all aligned on the same effort. Again, tied back to spatial, so you can put this same thing in the field in that particular location over that compressor, or it can just be while they're at their desk collaborating with the engineers.
All right. All this, and you're wondering, what is reality first? It's what we've learned. And our executive at that time said, you know what? I don't want you to create me a cost-plus environment. So I'll explain quite a bit, but if you look at this, that's what the colors, not the white, but those colors are what you see in your ERP systems. You only go down to a certain layer, that's what I'm trying to say. With the fidelity of reality capture, click it for me, please. Thank you. It gives you more contextualization. But it's even more powerful if you combine them. And so what we've learned, too, is, well, if you wanted to update the CAD model, what do? We go out and laser scan something. And afterwards, we go and probably send it overseas to have some low-cost engineering to model that. And that's great. How often are you going to do that? In our world, you got to do it pretty often because things change quite a bit. What we also learned is previous platforms, no matter how high the fidelity was, people still didn't trust that data because things changed. It was also a cost-plus environment. So that led us to, oh, okay, well, if you're already scanning, what if we just stop there? Because then those images is reality. And what we like to say is we're trying to bring consumer-grade experience to the industry. Because when you go home, when you're done with this conference, what do? Whoop. And there's a certain expectation already that you've been exposed to. Yeah, I'll doom scroll through as well, right? But long story short, our folks at our sites, they have a certain level of expectations already. And it might just be, hey, Google my satellite image, Google Earth, or so forth, right? When we started doing reality first, we gained trust. We created a cost-minus environment. And at the same time, too, then it led us down this exploration of, okay, well then, it's just a set of points. How do you group this together? Hence those spatial tags and the power behind the geospatial database.
And not just for the aspect of tracking equipment, but that's one of the biggest things that we're governing inside here, but also for those changes over a period of time. So you actually can gain that trust, making sure you tag in this visual world to show where something is potentially out of date. And really that context of what we're trying to build is an ever known, so not directly evergreen in every scenario, but ever known, so at least the person visualizing the information knows what's out of date. Now, how do we maintain those changes over time? We're continuing to work evolutionary on how we do that. And we think we need industry help on that for sure over the next 3 to 5 years. All right, call to action. So we talked about it a little bit before, that there's a couple of efforts that we're joining up with, this being one of them in the Reality Capture Network, but also some other ones. And we wanted to express those other ones that are going on right now, both from the aspect of how we're separating software from data, and we need to enable that, right? We need folks to join in on that journey or join in on that work effort to be able to go to scale, and join the journey for the industry work effort groups that we have going. And we'll talk a little bit about that right now.
So,
Open Asset Digital Twin, it's with the ARC Consortium. And so, what we're building, by the way, folks, I forgot to mention that. We're not building it for ExxonMobil. What we're doing is especially external engagements, right? We're doing something hopefully for the industry as well as multiple industries. But to do that, we can't go alone, right? You can't go back to vendors, solution providers to say, we're ExxonMobil, we want this. We have to actually socialize with our peers to say, are you guys having the same problems scaling digital twins? Are you even after that journey? What are your cruxes and so forth, right? And we needed a consortium to really help us be that change agent and really have that discussion, to really understand exactly, really, what are those problems, so that way we can have a collective voice together back to the community to say, the car that you built for us to drive on doesn't get as far as you promised us. And here's the feedback.
It's been great so far to see how much we're relatively aligned. What we'll also talk about, and you can scan that QR code, and it'll get you to a survey, but it'll also hopefully get you the contact information for that Open Asset Digital Twin group. Because this is a collaboration. This isn't just owner-operators of particular one industry coming together. This is hopefully a collaboration across many. Which is funny because we actually did a study of 216 companies, between our engineering service providers to our EPCs to our suppliers and all the rest of the owner-operators. And there's a lot of agreement in the aspect of growth on how we can maintain the cost of a digital twin over a period of time. I won't go through each one of these directly individually, but that cost is still too high. It's probably one of the biggest things that is that's on the list. And this is not, again, just from companies like ourselves. This suppliers as well. So they agree.
Folks that are on this journey,
Do you disagree?
just raise your hand. Like, cost of creating, is that a challenge for you folks?
Yeah.
Okay, a lot of people
We got
got
like
a lot
two
of money here.
hands.
Okay, good. Lack of expertise. All right, cool. Poor and inaccurate data quality.
Yeah.
All right.
Yes.
And then down to interoperability.
Awesome. We'll need to connect up for sure then. All right. It isn't, again, like we said before, it isn't just this aspect of the ARC advisory group has been the one that's helping us pull this together. It's a multi-industry and multi-consortium work effort. So please, this one is something that's near and dear to our hearts to help try to push forward, to help all of us at the end of the day. I think we all succeed whenever we get better alignment for what we want and what you guys end up wanting at the end of the day. I'll spend a little bit of time talking about the other one. We mentioned it at the very beginning, that periodic table. Well, there's a consortium called the Digital Twin Consortium. This one actually is mini industry already. So it's actually probably heavier, not our industry, and heavy every other particular one. I'll flash that up in just a bit here. That there's members from everything, from smart cities to airports to telecommunications to pharma to maritime, you name it. Representation from pretty much everywhere. And that there's a couple of big goals. There's a lot of working groups inside of there on pushing both data forward and particular use cases. The biggest thing that we've grabbed out of it so far is that aspect of aligning to this the capability periodic table. Scan that code as well, if you get a chance. And then I'll direct you to the people that are leading that particular effort as well. That periodic table is amazing. It helps just break down the particular components in each space. Not every digital twin is going to use each of the particular components, but hopefully the goal is that we can at least align on what's there and what's not there, and then what are some potential industry things that need to be solved.
Okay, we made it. Gave you guys an overview. We provide you guys really open and interoperable, right? It's a data play. And we talked about the use cases leading to reality first, followed by a call to action.
It's not over yet, though.
We'd like to leave you guys with a video of the great work that the team's been doing, as well as our ecosystem partners. This is how ExxonMobil has moved to a visual way of working, folks.
From laser scanning to virtual reality, 3D models and other digital data captures are quickly becoming must-have technologies in our industry. Globally, ExxonMobil has spent tremendous resources on independent 3D efforts, from capture to creation, and even purchased visual assets. These 3D models help us gain better insights, make informed decisions, visualize disparate data, and streamline innovation. However, many of our 3D assets are stored in various locations and used locally when they could be leveraged across ExxonMobil facilities. As part of a company-wide initiative, we're establishing a digital reality ecosystem, which will serve as a foundation for our 3D visual assets platform. This ecosystem will help us capture 3D models in formats that everyone can use, centralize where they are stored, and automate the way they are delivered, so they can be used by anyone, at any time, from anywhere. This ecosystem will allow us to move toward a more visual way of working with contextualized data, which will be essential to our success for corporate scale and integration, now and in the future.
hopefully you all enjoyed that video.
Shout out to Ethan Capps for the music. He made that on the fly and shared that with us. So huge kudos to him. If you guys get a chance, look him up. He's on Facebook. Really good DJ.
Thank you all so much.
Thank you, guys.